Here's SP8 Energy, forces doing work. You're supposed to be able to describe the changes involved in the way energy is stored when systems change. So what that means, when a system changes, that could be a car braking, which would be kinetic energy stored in the car getting turned into heat energy stored in the brakes. It could be a light bulb, where there'll be electrical energy getting turned into light and heat energy. Draw and interpret diagrams to represent energy transfers. So an energy transfer diagram, for example, for a bulb would be electrical energy going in and it's getting converted into light, useful energy, and heat, which is wasted energy. Explain that where there are energy transfers in a closed system, there is no net change to the total energy in that system. What that basically means is what goes in must come out. So it's the law of conservation of energy. For example, if 200 joules of electrical energy goes in, 200 joules needs to come out. Now, not all of the energy that comes out will be useful. There's only 80 joules here that's actually useful. 120 joules is being wasted. But it's still there. 200 went in and 200 came out. You just can't use this wasted energy for any further useful energy transfers. Identify the different ways that the energy of a system can be changed through work done by forces, which basically means mechanical work. And that's when a force moves an object through a distance. Using this equation, work done equals force times by distance. Electrical equipment. So electrical work, for example, could be charges moving due to a potential difference or voltage. And heating, well, that would be something like heat energy transferring from one place or object to another due to a temperature difference, which can be caused either electrically, but from current, or by chemical reaction, for example, burning a fuel. Describe how to measure the work done by a force and understand that energy transferred in joules is equal to work done. There we go. Energy transferred is equal to work done. Now remember, work done is force times by distance if you're talking about it in a mechanical sense. In other words, when you're moving things. Recall and use the equation work done equals force times by distance. So there it is there, W equals F times by D. But you could also see it as E equals F times by D, because remember, work done equals energy transferred. So it's just a case of you putting the numbers in. Describe and calculate the changes in energy involved when a system is changed by work done by forces. So in other words, it's just energy transferred equals force times by distance. So they'll just give you the numbers, you've just got to pop them into your calculator. Recall and use the equation to calculate the change in gravitational potential energy. So again, it's just this equation, and you've just got to pop the numbers in. So the change in gravitational potential energy equals mass times by gravity times by change in height. Recall and use the equation to calculate the amount of energy associated with a moving object. In other words, you've got to be able to calculate kinetic energy using this equation. Kinetic energy equals a half times by the mass times by the velocity squared. Make sure you square the velocity first before you do anything else. Explain using examples how in all system changes energy is dissipated so that it is stored in less useful ways. In other words, you always lose energy as heat and sound, and it goes to the surroundings. And that's usually because of friction. Explain that mechanical processes become wasteful when they cause a rise in temperature, so dissipating energy in heating the surroundings. Well, that's what I've just said there. Mechanical processes, in other words, it's friction. When objects move and rub, it causes heat and sound, which dissipates to the surroundings. Try to memorise that statement there. It could be worth up to 3 marks. Define power as the rate at which energy is transferred and use examples to explain this definition. For example, that ties straight in with this equation. The power equals energy transferred over time. Power is measured in watts and energy is measured in joules and time is measured in seconds. So 1 watt is equal to 1 joule per second. And there we go there. Recall that 1 watt is equal to 1 joule per second. And recall and use the equation for efficiency. So efficiency equals useful energy transferred by the device divided by the total energy supplied to the device. For example, a bulb. If we put 200 joules of electrical energy in and 80 joules gets turned into useful light and we've wasted 120 joules, to get the efficiency you do the useful energy that came out divided by the total energy that you had to put in. So in other words, 80 joules of light energy came out, we had to put 200 joules in, 80 over 200 comes out as 0.4. Now if the examiner wanted you to express it as a percentage, multiply that by 100 and it comes out as 40% in this case. So best of luck with your exams and good luck for your future. Work hard, be nice, and bye for now.